This is question 1 of M7. It looks simple, but it's actually one of the harder ones. So again, if you look at the past exam, this one, you'll see a very detailed solution, but I want to go through this again in case the notation is not that clear. So here we are going to find the naive Bayes classifier, what class it is classifying as. So it's basically one of the numbers from 1 to 29. So it's not a 0-1 classification. There are multiple classes. So remember, the naive Bayes classifier is just find the y that maximizes the posterior probability. So the posterior is basically y is y, given x1 is 1 and x2 is 0. So they are from here. So we need to compute the expression for this probability for all the possible y's and figure out which y occurs with the largest probability, and then we'll just classify it as that class. So now let's try to do that. Argmax of y, probability of y is y. Remember, when we get these conditional things, we always use the definition and divide it by x1 is 1, x2 is 0. So now we are maximizing by picking a y, and we are dividing all of these by a constant that's independent of y. So independent of y, so we can get rid of that. Then next step, argmax of y. This is just, remember, from the general Bayesian network, it's just everything given the parents and take the product, and x1 is 1 given y is y, and x2 is 0 given y is y. Y does not have a parent, and all the x have the same parent and they are independent. That's the definition of naive Bayes. And let's continue with this. Y equals to y. We have this. So 1 over 29. Again, a constant. We can get rid of this later. And x is 1 given y is y. We have that exactly. And x2 is 0 given y is y. This is x2 is 1 given y is y. But x can only take on 2 values, so we know that it's 1 minus that. Okay. Argmax of y. So now we can get rid of the constants again, so we can multiply this basically by 29, 30, 16. So this will be argmax of y, y and 16 minus y. So now it seems something that's kind of manageable. So here you can do the geometric hack. It's basically what kind of rectangle maximizes the area. So we have one length is y, the other one is 16 minus y. So you know that if the perimeter is fixed, then the largest rectangle is a square. So we have this 6 by 6 thing. And I mean 8 by 8 because they need to be equal to each other and y is 8. You can either use that logic or you should do what we are doing like all the time, like take the derivative and set it equal to 0. So this is the y such that the derivative is exactly equal to 0. So this is the y such that 16 minus 2y is 0. So this is our y.